Hey guys, it is Matt Grandy here with Dyeco Incorporated out of Harrisburg, Pennsylvania. Today I'm in my home garage. I got a little weld shop at home. I do some welding in the evenings, but someday we're going to do a shop tour and I'm going to show you our Dyeco facility, our training area, and all the equipment that we got and all the, I like to call them toys, all the toys that we have. But I think you guys would get a kick at them. So someday we're going to do that. But today what I wanted to do is bring to light or bring to foresight or bring to, the head here, a rod that we talked about in the past. It is our stick electrode called Dyeco Alloy's Super Alloy SP. It's a super alloy and the SP stands for stud pull. Now, where you would use this is if you had a broken off stud or bolt, whatever, below the surface. You can actually take this electrode, drop it down in the hole, light it off on top of the broken stud or bolt, work this thing around, basically recasting that hole, refilling that hole back up without, this is the key, without welding to the sides or the threads. It's pretty neat. Some of you guys might have heard of it before, but it'll get you out of a jam pretty quick. The slag on these electrodes are designed to roll out. So what happens is it rolls out, it protects the threads, your filler builds up continuously and gets you back up to the top. Now, depending on the depth, your chances are you're not going to get it all in one shot. You'll get it lit. You'll build metal up in there. You'll work it around, keeping it perpendicular to the top of the broken off stud. You'll work it around. What you'll see is the arc starts to flutter, and it's starting to flutter because you have too much slag build up in there. So you got to stop, chip it out with a chipping hammer, blow it out. I like to blow it out. Go back in and relight it until you get to the top. Once you get to the top, what you do at that point is you lay down a washer. You take a nut, you lay that on top of the washer. And then once you get to the top, instead of keeping your rod perpendicular, you're going to work this rod around that nut. You're going to actually weld your buildup, your filler that you just put in there, to that nut. Let it cool. Let everything cool back down to a touch, and then start working that back out. And 9 times out of 10, you can back it out. Now, you're coming up through all that slag, right? So it's going to be gritty, it's going to be grinding, but if you take your time, it's going to work. These electrodes are a nickel chromium electrode. They are 120,000 pounds per square inch tensile strength, which how that's measured is exactly how it sounds. If you would weld 1 square inch of weld together and then try to pull pull that piece apart, it would take 120,000 pounds for that weld to pop. It would start to stretch. That stretching is called elongation. The elongation on this stuff is about 24%. So it stretches almost 1/4 of itself before it tears. So when you're welding onto something hardened like a broken off stud, or any type of hardened wear plate, something like that, that elasticity or the elongation of the weld deposit is huge. These rods, on here, the actual verbiage on the actual electrode, and we put it on every one, it says Dyeco Super Alloy SP Superior Dissimilar Steels. So it's superior for welding dissimilar steels. All right, and dissimilar steels have different tensile strengths. They have different chemistries. They have different cooling temperatures. They come down. So there's a lot of stress in a weld. So when a weld cracks or it cracks beside the weld, it's usually because there's a lot of stress buildup in there and something tears or lets go. So if you give it the elongation in combination with the high tensile strength, what you get is a cushion. And that's crucial. So not only can you use this for stud extraction, but you can use it for welding dissimilars. You can weld anything from low alloy steels, high alloy steels, manganese steels, tool and die steels. Stainless, you can weld stainless. You can weld chromoly with this. You can weld spring steels and high carbon steels. The really, really cool thing is, because of its high tensile strength and its elongation, you can weld all those things I just listed to each other. So if you have a mixture of, say, for some unknown reason, you'd have to weld a piece of spring steel to a piece of stainless. Can't think of an application for it, but if it would come up, you could do that because of the 120,000 PSI and because of the 24% elongation. So on top of the stud extraction, just know it's been called the handyman rod. The advantage of this in a shop is, especially a maintenance repair shop, you have a product come in or a job come in and you're not 100% sure of that base metal. You use a 70-18 or 60-10 on it, or a grade of stainless, a 308 electrode or something like that. There's chances that they might not be compatible with the base material. With a rod like this, you're pretty much covered, which is really cool. You're covered on a lot of different products. I can't really think, you can't weld aluminum with this, obviously. And you can't weld cast iron. The reason you can't weld cast iron is cast iron, not cast steel. You can weld cast steel, but you cannot weld cast iron. Cast iron can be up to 5% carbon, okay? Cast steel is typically around 0.4% to 0.5%. So there's a big range difference in between the two. But because of the higher carbon content in cast iron, this rod, you do not want to use on it. And what happens is, some of you guys may or may not have heard about hard facing and chrome carbides. Hard facing is you put a layer of wear protection on the outside of a cutting edge, on the outside of a bucket, on hammers, on a mill, anything like that, to protect the actual part from wearing. You want it to be hard. With that hardness typically comes brittleness. So the one thing you don't want with a weld is brittleness. So I told you earlier that these rods had chrome in them, nickel chrome. That chromium mixes with the carbon from the cast iron and forms a chrome carbide, which is hard and brittle and equals, cracking, things like that. So what you don't want to use these for is cast iron. Obviously not aluminum either. So, but anything else, you can weld it with these. So I'm gonna get the camera flipped around here. I'll show you what we're looking at, and we'll go from there. This is gonna be the second part of the actual how-to hands-on. But once again, just to reiterate, we are talking about Dyeco alloys, super alloy SP stick electrode for stud extraction. All right, so I got the camera flipped around, and what I did here, since I didn't have an actual part, or something I actually needed to get a stud out of, what I'm gonna do is simulate something that's broken off. All right, so all I did was I took an annular cutter. This is 1-inch plate. I punched a 9/16 inch hole through the plate. I'm taking this piece of carbon steel, mild steel behind it. All right, I'm gonna slide it underneath like that. And what I'm gonna do is I'm gonna light off in that hole. And I'm gonna work it around like this. I'm gonna be very aware of getting a good arc established right on that plate on the bottom, which typically, or in a real life situation or a real repair situation, would be the top of the broken off stud. All right, so what I'm going to do, my goal here is to cast this 1-inch hole, 1 inch deep by 9/16 diameter with this rod, and then be able to remove this plate from this plate, and I should have a 1-inch nipple, or 1-inch, whatever you want to call it, I guess nipple, tit, whatever you want to call it there, left to show you guys that these electrodes do just that. One, you can stack and build them up, and two, that the rod itself will not weld to the walls of the hole. So let's get started on that. All right, guys, now to get started, just a few pointers or I guess suggestions is starting with a full 18-inch, I believe, 18-inch long electrode, and dropping it down a hole like that is perfectly fine. The deeper the hole, obviously, the more opportunity you have to nick the size, which would, you know, in a real world application would be threads typically. So if it's a narrow hole, you know, and it's harder to get to the bottom, sometimes what I like to do is burn off about half the rod. Now I have more stability, more control of making sure that when I drop this down there, that I'm not gonna nick anything. The other thing is you want to make sure that when you light off on the bottom of that hole that you're getting a good weld in. There's nothing worse than building that whole hole back up, getting it up to the top, and then it letting go and not having good penetration and not burning into the broken off stud. So right now, you know, this is 1 inch thick. The backing piece that I have in there is I think 1/2 inch. I have my machine set at about 117, 118 amps. DC electrode positive. All right. The other tip is when you light a stick electrode, you light it off, you got to scratch start it and mess with it, right? What I like to do, and if you have the area to do it, is have a piece of scrap metal handy, okay? Light it off on that initially. Get that tip. Get the tip up here glowing red hot, and then get your butt over here and drop it down in there. It'll take off immediately. You're not in there banging around, you know, increasing your chances of screwing something up. So that being said, let's light this first one off and see how she goes. So you guys probably aren't going to see much once I light this off as far as what's happening here, but all I'm doing is making sure that this isn't side arcing and blowing out some way. So I'm going to keep a super tight arc, and I'm going to keep it pretty much in the center, but I can move it around a little bit. I don't want to get too crazy with my whip or it will catch the edge, but this slag is designed to roll out, and as it rolls out, it protects the threads or the outside of the hole, you know, the outside wall of the hole, and that's the name of the game. Once you nick those threads or weld it to there, you're pretty much you're hosed. So as long as you keep her straight up and down, keep a tight arc, you shouldn't have any issues. So right now I'm at about 115 amps with 1/8 inch rod, 9/16 inch diameter hole, 1 inch thick. Now I'm gonna light her off, get her hot, and I'm gonna drop it right in there. I don't know if you guys can hear that or not, but the arc starts to flutter. As the arc starts to flutter, what's happening is the slag is drowning out your arc. All right. I really can't get to the bottom. If you had a needle scaler, you could. You know, patience is a big part. Patience is a big part in doing something like this. So we have a whole inch to build up. There's one pass. get out of it again. You can hear it shrinking. Now more or less, I can hit the bottom. If you would nick the side, at this point when you're chipping it, you're gonna be able to see that you nicked the side. So it's not the end of the world. If you have a small burr set, you can go in there and, you know, and clean it back up and detach it. But just inspect it before you light up again, you know? Make sure you don't want to bury that at the bottom if you are fused to it. Like I said, as long as you keep that tight arc tight and keep that rod in there and keep it perpendicular, you're not going to fuse it to the side. I'm going to look down in there, make sure everything looks honky-dory. Excuse me. Now I got a fresh rod. So this one should light right off. And I can see the bottom now. I'm about, I don't know, maybe a quarter of the way up. Breaking all that up. Taking my time. The other thing that's beneficial to getting this stud out, it broke for a reason, right? So most of the time you're heating bolts to expand them, and then as they cool, they contract and usually break that seal or rust or whatever's holding there, corrosion. So this, you're doing the same thing, except that nut is, or that bolt or stud is gonna be glowing red hot. So it's a huge advantage in that, you know, in that aspect. Just let it cool. You don't have to get every stinking little piece out. What you want to do is really expose the top, you know, the crown of your little bead that you're putting in there. So when you go to light off, you're ready to go again, you know. Say we're just about halfway. So with that being said, I'm going to probably shut up. I'm just going to keep repeating the same steps. And then I might you know, speed up the video through this so I'm not boring you guys. I'm gonna let that cool. I'm gonna go get a washer and a nut. I'll be right back. So now we're getting to the top. It's just about flush. Just about flush. You're gonna put a washer on there. The diameter, the inside diameter of the washer, you either want it the exact same size as the hole or slightly smaller, not bigger. If you let it bigger, what's gonna happen is you're gonna catch the outside edge of the base metal prior to hitting the edge of this, and you're gonna end up welding your stud that you just made to the plate or to the block or whatever you're working on. So you want to get that sitting down in there. Got a spatter beauty there. Have that lined up nice. Take some time, get it lined up. Your nut can be a little bit bigger. All right. So everything's lined up now. Now this pass, probably not gonna get into welding the nut to the stud yet. I'm gonna build it up one more layer. Gonna bring it up through that washer. And the next one after I chip this pass, the next one I'm gonna weld it to this nut. Now, because I'm doing a demonstration, I'm not going to go all the way through this, but this is what you would do. I can't do this if I'm doing a demonstration because it's not an actual stud I'm taking out. The stud that I'm making is actually welded to the backing plate, but this is how you would do it in a real job. A real job application, I should say. So get that all lined up. That's no problem, but that is why I use this plate. Didn't that time because I knew it was a fresh rod. I thought it'd light off and I wouldn't have any issues, but let's try it this way. Now, after I would chip that pass, what I would do next would be light off, and I'd bring this rod around and I'd weld the stud that I just made to that nut. I'd let it slow cool and I'd start working this out. Keep in mind, you have all that slag down through the threads, so there is going to be some resistance. You're probably going to have to chase out the threads, but you're getting that stud out, and that's our goal here. So with that being said, we're not using this nut, this washer, but you can see we're above flush right there. So to show you guys where we're at here, that is where we're at. Now you'd have that nut on the top here, and you could twist that little, twist it out. So once again, the product is called Dyeco Alloys Super Alloy SP. The SP is for stud pull. The super alloy part allows you to weld dissimilar steels, spring steels, manganese steels, anything with the exception of pretty much cast iron and aluminum. So if you're interested or you want to see it, leave us know and we'll be happy to show you. But you know, in a lot of instances, this product could help you, really get out of a jam. So thanks for checking us out. Like, subscribe, follow us on Facebook, all that good stuff. We appreciate the business. Thank you, and God bless.